Hi and welcome in this new video. My name is Mark Lemarty, Head of Customer Education at Astronomer, best-selling instructor on Udemy. And if you don't want to miss anything about Airflow, don't forget to subscribe to the channel and smash the like button for the YouTube algorithm. That will help me a lot. In this video, you will build a data pipeline to load data from a CSV file into a S3 bucket using the ObjectStorage API in Airflow. And if you don't know what it is, this is super useful if you interact with any object storage systems in your data pipelines. Then you will create a Spark cluster using AWS EMR and run a job to load the data from the S3 bucket into the new S3 table format, which is based on Apache Iceberg. So you can run analytic queries. Last but not least, you will use a special mechanism in Airflow to shut down the EMR cluster automatically to save cost. So without further ado, let's begin. To follow this video, there are a few prerequisites, and the first one is to have an AWS account. Otherwise, you won't have access to, well, the AWS services that we will use, such as EMR and S3. So make sure that you have access to an AWS account. And then the next step is to install the Astro CLI. If you don't know what the Astro CLI is, think of it as the easiest and fastest way to set up Airflow in local. To do that, you go to the following link and then install the CLI, you pick your operating system and you follow the instructions. It is pretty straightforward. That being said, even if you don't use the Astro CLI, it will work. You will just have few differences between your setup and mine. As usual, you will find the code and everything you need in the link in the description below on a Notion page. So the first step is to open your terminal and then create a new folder. So let's say Airflow-EMR, and then you go into that folder and you create your Astro project with Astro dev init. Okay, and now you can open your code editor from this folder and you will see that there are a bunch of files and folders that have been generated for you with the Astro CLI. So that's why you save a lot of time with it. So now we have that. The next step is to open your terminal. So as you can see here, I have a terminal at the bottom. Then go to the following link in order to download the zip file corresponding to this dataset. So this dataset is a big CSV file, 3 GB of data corresponding to some tickers of the stock market. So you download the zip file and then you unzip it and you create a new folder in the folder include called data. And in that folder, you put the CSV file all stock data.csv. And if you wonder what the data looks like, well, it looks like that. You have a bunch of columns, date, ticker, open, high, low, close, and so on, with a lot of data. But again, it doesn't really matter. It's just the data set that we will use in the context of that video. And by the way, maybe you cannot open that file because it's a pretty big one. All right, so what is the next step? The next step is to create the data pipeline. So let's do it. In the folder DAGs, we create a new data pipeline called etl.py. We need to make some imports here. So from Airflow decorators, import task and DAG. And the reason is we want to use the task-free API to create that data pipeline. If you don't know the task-free API, it is the new way to write your DAGs in a much easier and faster way. So then we use the decorator DAG. And we define the DAG just below ETL, and we call it at the end ETL, like that. Then for the DAG parameters, we will trigger that DAG manually, so schedule is known, and we don't have to specify a start date because the schedule is known, but we can still set catch up to false just in case. It's always a best practice. Okay, the first task to create is to load the CSV file into a S3 bucket. So you need to create that S3 bucket and you need to create the credentials, the access key ID and the secret access key in order to access your AWS account and so your S3 bucket from your data pipeline. I won't show you how to do that. It's pretty straightforward, but just make sure that you create a new bucket in S3. In my case, it is Airflow-stock-data. To interact with the bucket, we won't use the usual AWS operators. Instead, we will use the ObjectStorage API. And if you don't know what it is, it's a really nice feature as it provides a generic abstraction on top of object stores like S3, GCS, and Azure Blob Storage. That means you can manipulate different object storage systems without changing the code in your DAGs. And also, you can manipulate those object storage systems like if you were manipulating objects in your local file system. What it means that you can use methods like mkdir, touch, path, key, and so on. It's pretty cool to use that feature. So let's do it in your DAG. The first step is to import an object storage path, Airflow IO path, import object storage path, and then you create a new object storage path object corresponding to your bucket. So object storage path, and then the path to your bucket, which is Airflow stock data for me, and then the connection ConID AWS. We have to create the connection AWS. Let's start Airflow with Astro Dev start, then go to admin connections, and then add a new record. And for the connection type, search for Amazon Web Services. And by the way, if you don't find the connection type, you need to install the Amazon Airflow provider. And the connection ID is AWS. And then you have to specify the access key ID here and the secret access key that you should have created earlier from your AWS account. And you click on save to create the connection. Okay, now the connection exists. Let's go back to the code editor and let's create the first task. For that, we use the task decorator and we create a function local to S3, which will be the name of the task. Then we import polars. If you don't know what polars is, it is a much better version than pandas to manipulate data frames. And we will use polars in order to load the data from the CSV file into the S3 bucket as a parquet file. So after that, we can ensure that the bucket exists using the object storage API, and in this case, the object storage path corresponding to our S3 bucket with the method mkdir. And mkdir exists okay. If that returns no errors, it means that the bucket exists. Moving on to the next step, we create a new path corresponding to the bucket slash and the name of the file, the parquet file that will contain the data from the CSV file. Then we read the data using polars and we open the parquet file, but we are actually manipulating a file that doesn't exist yet in our bucket. And that's the beauty of the object storage API, is that you are manipulating the object storage system like if you were in a local file system. And then we write the data from the CSV file into the parquet file using polars with the method writeParquet. So just like that, with the object storage API, you are able to load the data from the CSV file into a parquet file in a S3 bucket. And I think we agree that it is pretty straightforward. The last step is to return the path of the bucket that we have defined right here as a XCOM that will be used by another task, as you will see later. Okay, so at this point, we are able to load the data from the CSV file into the bucket as a parquet file. Nice. The next step is to create a second task in order to create the Spark cluster using AWS EMR. First, go to the link in the description below, and on the Notion page, you will find the code corresponding to the configuration of the Spark cluster that we will create. And then you can create a new folder in the folder include called Spark. And you create a new file in that folder Spark called emr.py. And you copy and paste the following code. Okay, let me give you some explanations. Remember that we will use AWS EMR to load the data from the S3 bucket into an Iceberg table. And for that, we enable Iceberg, as you can see here, and we also configure the S3 tables bucket. And one thing that you need to replace is this value. And you have to replace this value with your own S3 table. For that, you go to AWS S3 and then table buckets, and here you create a new table bucket with whatever name you want. In my case, it is Airflow stock lakehouse. And then you need to copy this value and then you paste it here. Okay, so make sure that it is your table bucket. Then if you scroll down a little bit, here we configure the cluster, the AWS EMR cluster. We give the following name, Spark Iceberg cluster, with the following version for the EMR. And then the applications is Spark, and the logs will be stored in the bucket airflow-stock-data. So exactly where you have uploaded the data, the parquet file, earlier in the first task. And then we define the instance that we would like to set up, m5.xlarge. And there are a few things that you need to configure as well. The first one is the EC2 subnet ID. You have to create a subnet here. For that, you go to AWS and then you search for subnet VPC feature, and then you can create a new subnet from here. Once you have done that, you copy the subnet ID and you paste it here. Last but not least, you need to create the two roles, EMR default role and EMR EC2 default role. For that, you have to use the AWS CLI, so please, if you haven't installed the AWS CLI, do it now. And once you have the AWS CLI, you can run the following command in order to create the two roles, default role and EC2 default role. And then don't forget to attach one policy, this one, in order to give access to this role, the S3 tables. Otherwise, you will get an error. Okay, that's it for the configuration of the cluster. Now, if you open requirements, there are two packages that you need to install. The first one is Apache Airflow providers Amazon with S3FS, otherwise the ObjectStorage API won't work. And also you need to install Polars, as we use Polars to upload the CSV file into the S3 bucket. Okay, so make sure that you install those two Python packages. Back to the DAG, the next task to create is for creating the AWS EMR cluster. And Airflow has a couple of EMR operators that we can use. So first, let's import those operators with the following line. So Airflow providers, Amazon AWS operators, EMR, and we import EMR create job flow operator, EMR add steps operator, and the EMR terminate job flow operator. So let's use EMR create job flow operator to create the cluster. So after the local to S3 task, we create a new variable, create job flow, equals to the EMR create job flow operator. The task ID is create job flow, then the AWS connection ID is AWS, and the job flow overrides is the cluster config that is specified in the file emr.py. So that's why you need to import cluster config, and for that you just need to type from include spark.emr cluster config. Okay, so just like that, you are able to create the AWS EMR cluster using the configuration that we have set up in the file EMR. Now we have the task to create the EMR cluster. The next step is to create the task that will run the different steps in that EMR cluster. So for that, we will use another operator. So just after create job flow, you create a new variable, add steps, equals to the EMR add steps operator. And then the task ID is add steps. Then the AWS connection ID is AWS. And you define the job flow ID, which is the output of the previous task, create job flow. So create job flow.output. Behind the scene, you are getting the XCOM that it is automatically pushed by the EMR create job flow operator, which is the ID of the EMR cluster that you create. And then the steps. So that's the tasks that we will run through the EMR cluster. You will see that just after. And then deferrable to true, we want to use the deferrable version of the EMR add steps operator to save cost. If you don't know what is a deferrable operator, I strongly recommend you to take a look at it in the documentation of Airflow. It is a way more efficient way to run operators that are waiting for something to happen. And last but not least, wait for completion. We want to wait for the steps in the EMR cluster to complete before completing this task. For the steps, the tasks that we want to run through the EMR cluster, you will find them in the link in the description below on the Notion page. But basically, you have to create a new file in the Spark folder that you can call spark_steps.py, and then you copy and paste the following code. So let me give you some explanations. It is pretty straightforward. The first step is to create a namespace, and we run the following SQL request, create namespace if not exists, S3 tables bucket.data. So we will create that namespace data in the S3 tables. Important thing to note, the S3 tables bucket refers to what we have specified in the configuration of the cluster right here, S3 tables bucket. So it is important that you keep the same name here. Then after that, we want to create a new table, and for that, we will use this SQL request. That table will be raw in the namespace data, and it corresponds to all the columns that we have in the CSV file, but it is an iceberg table, as you can see here. And last but not least, we have this task that runs the following Python script with Spark in order to write the data from the parquet file in the S3 bucket into the iceberg table. And you can see that we pass the following input, which is the output of the task local to S3, corresponding to where the parquet file is in the S3 bucket. As usual, you will find the code of this Python script in the link in the description below on the Notion page. Create a new file in the Spark folder that you can call load to iceberg.py, and then you copy and paste the following code. Again, it's a pretty basic PySpark code. So as you can see here, we take the input that we pass. Again, this is the path to the parquet file in the S3 bucket. Then we set up a Spark session and we do the following things in order to write into the raw table that we've created earlier, the data from the parquet file. And that's how you load data from parquet files into Iceberg Tables. Keep in mind that we run this script from the bucket, from your bucket. So you have to change this value with your bucket and then make sure that you upload the load to iceberg Python script into your bucket. Make sure that you upload the script as shown right there. So you should have this file in your bucket. Back to the data pipeline, make sure that you import the steps. So here you type from include spark.spark steps and then import the steps. And now the last task to create is to terminate the EMR cluster. So after add steps, create a new variable terminate job flow with the EMR terminate job flow operator. And this one takes the following task ID, then the following job flow ID that comes from the previous task. And that's why we are using .output. Remember that behind the scene, output is a XCOM pool with that key. And finally, the following connection ID, AWS, to connect to the EMR cluster. And with that task, we will be able to terminate the EMR cluster. Now we need to define the dependencies. And naively, you could think of defining the dependencies like this. So create job flow, and then add steps, and finally terminate job flow. However, imagine that there is an issue here with the add steps. But just before, you've created the EMR cluster. In that case, the terminate job flow task will never be executed. And so your EMR cluster will keep running, and that will cost you quite a lot of money. So that's why you want to avoid that. You want to make sure that whenever you create the cluster, regardless of what happens between create job flow and terminate job flow, you want to make sure that terminate job flow is always executed if create job flow has been executed. If the EMR has been created, you want to make sure that you always delete that cluster. And this is where you need to use an Airflow feature called Setup and Teardown tasks. I recommend you to take a look at the documentation for this feature, but the key features of Setup and Teardown tasks are the following ones. If your clear task, its setups and teardowns will be cleared. By default, teardown tasks are ignored for the purpose of evaluating diagram state. A teardown task will run if its setup was successful, even if its work tasks failed. And teardown tasks are ignored when setting dependencies against task groups. Again, this feature is truly useful to avoid keeping some resources up, whereas they should have been terminated. So let's go back to the DAG, remove those dependencies, and then we will use chain to avoid using the right bit shift operator. Then we call local to S3 to upload the CSV file into the S3 bucket as a parquet file. Then we call create job flow, then add steps, and finally terminate job flow, and we call the method as teardown, and we define the parameter setups with the task create job flow. And just like that, we are saying that we have two tasks, one corresponding to the setup, create job flow, and one corresponding to teardown, which is terminate job flow. So whenever create job flow runs successfully, terminate job flow will be always executed. Don't forget to import chain. So at the top of the file, you can type from Airflow models base operator import chain. You save the file and you have successfully created the data pipeline. In fact, if you go to the Airflow UI and click on the DAG, then graph, you can see the different tasks, and more importantly, you can see those dots that indicate the setup and teardown tasks. So again, whenever create job flow runs successfully, terminate job flow will be executed as well. So that's why you can see those dots. All right, so now the last step, just in case you forgot, you go to connection, make sure that in your connection, you specify the AWS region as an extra value. So here you create this JSON value, region name, like that, and specify the region of your AWS account where you have created the S3 bucket and everything. So in my case, it is US East 1. So let's go back to the UI, US East 1. And by the way, when I'm recording that video, S3 tables are not available in other regions, I believe. So make sure that you use US East 1. Okay, all right, so click on save. And now let's run the DAG to see if it works. For that, you just need to trigger it. Then click on the DAG and let's see if it works. So you can see that the task local to S3 is running, and that's gonna take a bit of time as the file is pretty big. Okay, it looks like the EMR cluster has been created, and we can verify that by going to your AWS account and then look for EMR. Then click on the service, and you should be able to see your EMR cluster running right here. So you see, starting, let's click on the cluster, and then steps, and you can see the 3 steps that we have defined in the step file. So let's wait for those tasks to run and complete. By the way, the task add steps has the following color indicating that the task is deferred. And that means while this task is waiting, it doesn't take any resources, it doesn't take a worker slot. In fact, if you go to admin and pools, you can see that no running slots are used because the task is deferred. So that's why deferrable operators are truly useful. You can run other tasks while some tasks are waiting. All right, it looks like it worked. As you can see, all the tasks have been successfully completed. And in fact, if you take a look at your DAG, you can see that all the tasks have been indeed successfully executed. And if you go back to AWS and go to S3, and then click on the service S3 and go to the tables right here, table buckets, and click on your table bucket, you should be able to see one table row in the namespace data. And that means at this point, you have successfully created a data pipeline that loads data from a parquet file in a S3 bucket into an Iceberg table in a S3 table using PySpark. And you have the setup and teardown tasks to make sure that you always free up the resources that you create on your AWS account. So I hope you enjoyed that project, and I see you for another video. Take care.